Pi is the ratio of a circle's circumference to its diameter, a constant found in every circle, everywhere. No matter the size of the circle, the circumference is always a little more than 3 times the diameter. This ratio is called pi, represented by the Greek letter pi. Pi isn't a simple number, it's irrational, meaning its decimal expansion never ends or repeats. We often use 3.14 or 3.14159 comma, but these are just approximations. The true value of pi stretches on forever, a mystery that has fascinated people for millennia. Pi's story is woven through the history of human curiosity, from ancient civilizations to modern science. It's simple enough for a child to grasp. Measure a circle, compare its edge to its width. Yet its nature is endlessly complex. Pi is a cornerstone of mathematics, appearing in geometry, physics, engineering, and beyond. It links the perfect shape of a circle to the deepest secrets of the universe. Understanding pi opens the door to the world of mathematics. We use it to build bridges, design engines, and send rockets into space. Its infinite, non-repeating nature challenges our ideas about numbers and infinity. The history of pi is a testament to human ingenuity and our drive to find order in chaos. It tracks our progress in measurement, calculation, and abstract thought. Pi is both practical and philosophical, a symbol of our quest to understand the world. And so the journey of pi begins. The story of pi starts in the ancient world, where civilizations needed math to build, farm, and study the stars. The Babylonians over 4,000 years ago used 3.125 as their value for pi, close enough to build ziggurats and measure land. The Egyptians, building pyramids along the Nile, used about 3.1605 comma as found in the Rhine papyrus. Both cultures recognized a constant ratio in circles, even if they hadn't formally proven it. The Greeks took things further, seeking not just a good estimate, but a deeper understanding. They knew pi was a bit more than 3, but its true value eluded them. The famous challenge of squaring the circle, making a square with the same area as a circle, became a symbol of pi's mystery. We now know this is impossible because pi is transcendental, not a simple fraction. These early efforts laid the groundwork for future breakthroughs. Different cultures, working independently, all recognized the circle's secret ratio. The Greeks turned pi from a tool into a profound mathematical quest. The first major leap in calculating pi came from Archimedes in the 3rd century BC. He used polygons, shapes with many sides, drawn inside and outside a circle to trap pi between 2 values. Starting with hexagons and doubling the sides up to 96, he narrowed pi's value to between 3.1408 and 3.1428. This was astonishingly accurate for his time. Archimedes' method, called the method of exhaustion, was the first algorithm for calculating pi to any desired accuracy. His approach shifted mathematics from rough estimates to logical, repeatable proofs. For over 1,500 years, this was the standard way to find pi. Archimedes didn't just improve the number, he changed how we think about mathematical precision. His legacy, a new era of rigorous calculation. While Europe slowed, the quest for pi flourished in China and India. In the 5th century, Zhu Chongji in China used polygons with over 24,000 sides to calculate pi to 7 decimal places, an unmatched feat for centuries. He also gave us the famous fractions 22/7 and the even more accurate 355 113ths. Meanwhile, Indian mathematicians took a revolutionary path. Madhava of Kerala in the 14th century discovered an infinite series for pi, pi 4 equals sign 1, 1/3 plus 1/5, 1/7 plus. This was a leap from geometry to pure arithmetic. Though the series converges slowly, Madhava and his followers refined it to reach 11 decimal places. These advances showed that the pursuit of pi was truly global. China and India pushed the boundaries of calculation and theory. Their work set the stage for the next mathematical revolutions. After China and India's breakthroughs, Europe's progress on pi stalled for centuries, but the Renaissance reignited mathematical curiosity. Ludolf van Beulehen spent his life calculating pi, reaching 35 decimal places using polygons with billions of sides. So proud, he had the digits carved on his tombstone. This was the peak of the geometric approach, but it was slow and exhausting. The real breakthrough came with calculus and infinite series, inspired by earlier work from India. Mathematicians like Wallis and Gregory developed new series for pi, far more efficient than polygons. In 1706, William Jones first used the symbol pi, later popularized by Euler. With new tools and a universal symbol, pi entered a new era. The stage was set for the computational explosion to come. Pi was no longer just a geometric curiosity, it became a symbol of mathematical progress. The Enlightenment and calculus transformed the quest for pi. Euler connected pi to other fundamental numbers, revealing deep links in mathematics. The computer age changed everything. In 1949, ENIAC calculated pi to over 2,000 digits in 70 hours, a task that once took centuries. As computers advanced, so did the number of known digits. Thousands, then millions, then trillions. Today, we know pi to over 100 trillion digits. We only need about 40 digits for any practical purpose, but the race continues as a test of computational power. Pi is everywhere, in signal processing, GPS, engineering, and physics. It's essential for designing technology, analyzing waves, and understanding the universe. Pi has evolved from a geometric ratio to a fundamental constant in science and technology. Its endless digits are a benchmark for human and machine ingenuity. Pi's journey mirrors our own technological evolution. In a world where computers can calculate trillions of digits, why does pi still matter? Pi is more than a number. It's a gateway to the beauty and depth of mathematics. Learning about pi connects students to a story stretching from ancient geometry to modern science. Measuring a circle and finding pi's ratio is a hands-on link to thousands of years of discovery. Pi bridges arithmetic, geometry, algebra, and more, showing how math is interconnected. Its endless, non-repeating digits introduce us to irrational numbers and infinity. Pi sparks curiosity and critical thinking. Why does it appear everywhere, from circles to probability? Its history is a lesson in perseverance and human ingenuity. Pi is simple, yet endlessly complex, a symbol of our quest to understand the universe. The story of pi is the story of mathematics itself, timeless, endless, and deeply human.